Welcome to today's Explainer. Have you ever just stopped and looked at a towering oil refinery or one of those massive chemical plants and thought, wait a minute, how did all that colossal equipment actually get there? I mean, it doesn't just magically appear, right? And you definitely can't ship a 200-ton reactor via standard 2-day delivery. Today, we're diving straight into the invisible, kind of mind-blowing reality of moving multi-ton industrial machinery. It is an absolute puzzle, a sheer feat of engineering that has to happen way before the actual construction even kicks off. So let's get into it. So this brings us to the really big question. It's a massive logistical challenge. How on earth do you move gargantuan industrial machinery across long distances without, completely destroying everything in your path? Seriously, think about it. We are talking about equipment that weighs hundreds of tons and stretches for dozens of meters. Transporting these absolute behemoths from a manufacturing port all the way to some inland construction site, well, it's a super high-stakes puzzle. Engineers simply have to solve this before a single wrench is turned at the plant itself. Make one wrong calculation, you've got a multi-million-dollar piece of equipment stuck on a highway, or worse, colliding with everyday infrastructure. No pressure, right? To solve this crazy puzzle, engineers actually rely on a very specific type of vehicle. Say hello to the conventional trailer. Technically speaking, this is a heavy-duty, multi-part transport system designed specifically for the high-speed, long-distance hauling of ultra-heavy industrial equipment. But let's break that down into a way more beginner-friendly analogy, just so we can really wrap our heads around it. Imagine your standard everyday pickup truck towing a little pop-up camper for a weekend getaway. Okay, you got that picture? Now, take that exact same towing concept and scale it up to absolutely colossal industrial proportions. The physics are basically the same, but the scale and engineering required to make it actually work without snapping in half are truly remarkable. When you see one of these beasts out in the wild, it really gives you a true sense of scale. At first glance, your brain might just register, okay, really big truck. But when you take in the sheer size of the cargo being hauled across, say, a massive desert landscape, it's wild. While it operates on that same basic principle as a standard truck setup we just talked about, it is a highly specialized engineering marvel. Just think about the countless wheels required to distribute all that immense weight, simply to prevent the actual road from collapsing right out from under it. It's not just a vehicle, it's practically a mobile support system designed to keep industrial progress moving forward. Okay, so let's completely dissect what makes up a conventional trailer. It breaks down into 3 core components. First up, at the very front, we have the prime mover. This basically looks like a highly reinforced truck cab, and its one and only job is to provide immense pulling power. Right behind that, we have the drawbar. Now, I want you to think of this as a heavy-duty iron link. This link is absolutely vital. It's the connection bridging that front power source with the rear payload. And finally, connected to that link is the unit itself. That is the massive, multi-axle rear platform that is actually carrying the heavy equipment. These 3 distinct parts, the prime mover, the link, and the unit, they literally have to work in perfect unison to drag mountains of metal across entire continents. And here is the absolute superpower of the conventional trailer. 80 kilometers per hour. That is roughly 50 miles per hour. Now, I know, it might not sound like race car speed to you and me on our morning commute, but when you are hauling literally hundreds of tons of solid steel, 80 kilometers per hour is astonishingly fast. It's moving. This unique ability to transport immense weight at relatively high speeds is exactly why engineers almost always choose the conventional trailer for those long-distance inland hauls. It effectively shrinks the map, getting critical components to the site way more efficiently. Now, you might be wondering, why don't we use conventional trailers for literally everything? Well, it really helps to compare it to its cousin in the heavy haul world, the SPMT, or self-propelled modular transporter. As we just learned, the conventional trailer is your absolute go-to for high speed and long distances, specifically because it relies on that towing mechanism. The SPMT, on the other hand, provides its own power directly to its wheels. Because of this, an SPMT is incredibly agile. I mean, it can literally spin 360 degrees right in place. But the catch? An SPMT is painfully slow, barely reaching 20 kilometers per hour. That makes it pretty useless for long cross-country hauls. So, the conventional trailer definitely wins for distance, but that towing speed? It definitely comes with a major trade-off. And here is that trade-off. The Achilles heel of the conventional trailer is its exceptionally wide turning radius. Because the entire system relies on that drawbar towing mechanism, that iron link we discussed earlier, The rear unit doesn't neatly follow the exact path of the prime mover up front. Instead, the rear unit kind of cuts the corner. So making a turn becomes this sweeping, super cumbersome maneuver. It is definitely not nimble. If you need to make a right turn at a standard city intersection, the conventional trailer is going to need an enormous amount of real estate just to safely sweep that heavy load around the corner without crushing something. Because of that exceptionally wide turning radius, engineers can't just plug the destination into a GPS and hope for the best, right? Instead, they have to conduct what is called a route study. It's incredibly detailed. Imagine pulling up a highly complex CAD drawing with overlapping blue and purple blocks, tracking the exact sweep of the trailer. Engineers have to meticulously plot every single inch of the entire turning path. They map it out so precisely that they'll know if street lamps number 98, 42, 41, and multiple traffic lights need to be actively removed from the street just so this trailer can make one single turn. The level of calculation going on here is just staggering. The extreme lengths engineers will go to just for a tight turn are honestly unbelievable. It's a strict 4-step process. First, through that route study CAD, they identify the obstacle. Maybe it's a lamppost, a bus stop, or even a 100-year-old street tree. Step 2 is where it gets absolutely crazy: demolition and removal. They will literally rip up street trees and knock down physical structures to clear the sweep path. Step 3, the equipment is safely transported through that newly created gap. But step 4 is probably the most vital for public relations: full environment restoration. The construction company is legally obligated to replant those exact street trees, rebuild the structures, and completely restore the area so that it looks exactly like it did before this mega machine ever rolled through. So, I want to leave you with this final thought. Successful plant construction isn't just about the machines themselves, but the incredible, highly planned journey it takes to get them to the site. It really elevates our whole understanding of transportation, doesn't it? It's so much more than just point A to point B. The next time you see a sprawling industrial facility, I really hope you have a newfound respect for those invisible logistical miracles, the ripped up and replaced street trees, and those crazy route studies that made it all possible. Thank you so much for joining me on this explainer. So what logistical marvels should we dive into next? Until then, keep questioning how the world around you is actually built.